everyone. This is my final project for Coding Place 2026. It is related to a variational autoencoder. But what is it and what it is used for? Well, we want to address a problem or a challenge. For instance, when you are trying to give information to data analysts or ML engineers, you will have some problems if you give them raw data with your information or maybe your credit card data and things like that. That will be illegal. But you still want to give them valuable information that represents the variance of your data, the enough information that they can use to understand how's it going in the bank. So what can you do? You can generate new information. You need to, because you can give them the personal information. But how can you do that without having to do hand calculations and do that for maybe thousands, and maybe millions of data? Well, you can use something very interesting related to generative AI. In this case, is a variational autoencoder. This is a highly advanced generative deep learning model, which is not like other models that try to map it into a specific point and then getting something different. No, this model is not deterministic. So if you run it multiple times, you will get multiple results. This is important to know because it is based on probability. It learns the underlying probability distribution of complex, sensitive training data. And then, instead of memorizing exact data, it compresses information into a probabilistic latent space. Then, it uses the information on that latent space to reconstruct new data. This is made in two different phases. The first phase is the encoder, which gets data input and then compresses it, creating two things. The first one is the mu, and the variance. They use these two things to compute parameters for a probabilistic space, and then it uses it. But how can we use that? First, we need a third element, which is the noise. In this case, we name it Gaussian noise. Why? Because this is a Gaussian distribution, a normal distribution. In other cases, you might not want to use a Gaussian distribution, but that's not the case. So, we use something called the reparametrization trick, which is basically creating a vector using mu and the other data that you have, like the variance and the noise. So we create that vector, and then the decoder uses that vector to reveal data from what you've got. And then you get some new, excellent, perfect data to give it to your ML engineers, Q&A, and all of that, without compromising important information. So we wanted to create that, a variational autoencoder. This way we will give absolute privacy, safe analytics, and it might be used for anomaly and fraud detection cases. So let's get to it. Okay, so this is the web page. Basically here you want to upload your file, and then we can use this, for instance. Just a small parenthesis, you might want to train the model in your own information. That way it will learn your underlying data patterns and then replicates them in another dataset. So you're free to do it, you're free to use this code, maybe just for fun. And here you have to give it a dataset, a validation dataset in this case, and you can choose what volume you want. Maybe we want this amount, 3000, and let's create it. We generate it, and there you have it. For more information about the structure of the dataset, you can access it through the GitHub page. Here you have all the details, and you can download it as a dataset. But let's take a look. How do we know that it has been useful? Well, you have to go to this specific section where you can see that we have used principal component analysis to compress this high dimensional data that you can see here that has many dimensions. We have compressed them into 2 dimensions using the principal component analysis. This way, you can see that the model is actually a little bit close. It has generated this data, these specific points, and the real data is this one. It doesn't seem so bad. So how do we know if this is actually good? Well, we have this metric. This is very important. This has to be high, as high as possible. The higher, the better. So we have this feature analytics. This is another thing that we need to consider. Here we can compare the importance of the data between our dataset and what we have generated. This is very important. Why? Because by taking a look at the variance, we know how far is the generated dataset from the actual data. So we were saying in the first minutes that this is not a deterministic model. So if you give it something multiple times, it will generate something different every single time. Let's try. Oh, you can see that now it's a little bit more accurate. And then we can keep running it until we find some value that is closer. If you find some value that you want to save, you can download the dataset. And if you want to keep going, you can do it. You can keep generating and trying to find something that is more precise. In this case, we didn't accomplish that. But you can keep going and keep going, and at some time you might find something like this, which is pretty close. So we want to save it. You save it, and here you have your dataset. Simple as that. So this is my project. I use Streamlit for the interface, and all the other tech stack is defined on my GitHub, so you can take a look at it. And that would be everything. I hope you have enjoyed it. I hope you have maybe learned something, or at least have that curiosity that it is really important in computer science. So thank you and goodbye.